Hello, friends. Welcome back. It's been a while. I had to take a detour and upgrade everything. We were having some issues with iOS 17 Rehearsal Pro, so I finally need to get on to supporting that. In order to do that, I had to upgrade my Mac to Ventura. I did not go to Sonoma because I like staying on usually one major version back on Mac OS for stability. And Ventura is the minimum required, which is 13. There it is, Ventura 13.6.4, to upgrade to the latest Xcode 15.2. And 15.2 is required in order to build to iOS 17. I do not have an iPhone 15, so I'm using the Simulator Pro Max. It's the largest possible phone size. I believe it's the biggest. And one of the ways I can know is I have this nice convenient spreadsheet over here of mobile devices that I put together a while ago to keep track of all the Apple devices and a handful of Androids, all the versions, what we need to support, and all that. So as we can see, we're up to now iOS 17.3. iPhone 15 came out on 17.0, so that was its default upgradable. And this did a little twist to us, and that little twist is we now had to raise the minimum iOS for the app, at least in future releases, to from, sorry, in the wrong fingers here, from 11 to 12. So once you upgrade to iOS 15, you cannot have a minimum deployment less than 12. It's been moved up. There's probably some way to patch this. I've seen some stuff online where people can try to retrofit it, but I think we're just going to go with the standard approach here. So this had to be changed to 12.0. All the pods had to be upgraded to 12.0. And I slammed into a couple of issues when I did the upgrade. One of which in particular was related to a Google library. Google, that's not quite in there. Let's see. Well, easier way is to do a get log name status. Let's see, Google. There we go. Google data transport. So this is kind of a funny commit that was necessary. And that is that Google originally wrote this C code, Objective-C code. That's not it. That's not it. That's not the right one. Sorry about that. Let's try again. Yeah, fix these. Control copy, git show. That looks right. So it's ostensibly Objective-C, but it's really C code. And you can see that without putting void as the argument, Xcode is now decided, or the newer version of Clang, whichever it is, has decided that it doesn't like that, and it will generate this error. Now, of course, I could have gone in and done a full upgrade of all of these pods to their latest, which is incredibly risky. I prefer stability over being on the upgrade treadmill of you've got to be on the latest everything unless it's necessary. And Google Data Transport actually gets pulled in as a pod to support all these Firebase pods that are being used by the app. And just imagine if I were to say, upgrade to the latest Firebase, what kind of ripple effects I could be chasing for days, weeks, months. If this stuff works, let's not worry about it. I did not upgrade this to a newer version of the library because that probably would have broke a bunch of other things. I simply fixed the source. I mean, it's just a couple of changes here to the source code. So that solved that problem. What other stuff did I... Let's see, regarding upgrade, little snafus. I just had to re-execute pod install I did not upgrade pods itself. Did not upgrade the version of Ruby that it sits on top of. This seemed to work fine. And what do we got here? Oh, it did upgrade CocoaPods. Note that Xcode can no longer build without a JVM. This is old. This is way old. That's a long time ago. Yeah, no. That's pretty much everything I needed to do to upgrade Xcode. These other things are fixes that I made for iOS 17. So this is all I really, yeah. There was actually a shell script again inside here. Let's take a look at this really quickly. It's the last fix that I had to do. I do a git show on it. Yeah, this is a shell script inside pods that it generates when you do the install. And something happened here with, as you can see, simply an argument changed to rsync. Uses rsync, which is built into Mac OS, I believe, and upgrading to Ventura must have changed rsync, which broke this. And then again, I could have upgraded pods, but I didn't want to run that risk, and I found some help online. Somebody obviously already ran into it on Stack Overflow. So I give credit where I get fixes into my commits. This was the easier fix. So that got us there. But in order to do all of this, there was another problem that required upgrading KMP to the latest. And this is where it got a lot bigger and a lot tougher. Let me turn this off. And it's this bright white. Sorry about that. It's Google Sheets. Let's just go get rid of that. There may be a dark mode for it, but I couldn't find it. And I didn't want to spend time chasing it down. And yeah, we could see here's the upgrade. So the upgrade on the Android side is a lot more involved. And it's one of the reasons why I don't do it too often. I've worked on a couple of Android projects where I've had to do major upgrades midstream, and I could spend days chasing down compatibility issues and figuring out how to synchronize this version with that version. Excuse me. But in this case, I'm going to pause just for a second. Okay, I'm back. Why did I need to do this? Because something got actually fixed in Kotlin 1.8.10 that I needed. Actually, let's look this up. Kotlin, yeah. Multiplatform Mobile, Swift binding. No, we don't want that. We want to say, just show us, what is it, 1.8.10? 8.10? Releases, here we go. Right here, 0.8.1. Fixed an issue running on iOS devices with Xcode 15. And I was on the previous release somewhere in here. This is the, I believe this is the actual plugin. Yeah. So this just kind of shows how complicated Kotlin Multiplatform is. I would say it is the most complicated setup for development I've probably ever had to do. And that begs the question, is it worth it? Well, in my case, I still feel like it's worth it. But just to give you a feel for those of you who haven't done a lot of Android development or Kotlin Multiplatform, you know that, or you don't know, that when you do upgrades, you've got a lot of things that get touched. So you've got the JDK version. And just to give you a feel, let's show you what all the upgrades look like here. Did I copy that? Let's copy that. Let's do a git show. So these are all the upgrades that were needed. I was already running JDK 17, but if you aren't, you needed to bring it up. And then we needed to add this because there was a conflict between Kotlin and Java, even though I was currently already set for the JDK. By the way, if you don't know where it is, it's kind of buried. You have to go into settings. It's down here under, it's under the Gradle stuff. Actually, let's just do a search for JVM. There it is. It's here. Boom. So settings, build tools, Gradle JDK, and you can select from a bunch here. I've been using this one for a while, just the 17. Actually, I was trying out 19 for a while, but it seemed like it wasn't compatible with a lot of things I was doing, so I just stuck to this. But this was already set, but even though it was already set, as soon as I upgraded, I slammed into a problem where, for whatever reason, it needed these compatibility declarations because it was trying to go out to Java 8. I don't know why it didn't do that before, but that was necessary to fix the problem. So we've got a JDK version. We have a Kotlin version. Let's take a look at this again, which is inside our top level Gradle, right? So Kotlin version. And you could see previously I was on, what was I on? 1.8.10. I moved up to 1.9.20. There is actually a newer version of Kotlin, but I wanted to stay on the one that matched what I was using. There's like a .2 bug fix. Didn't seem to apply to anything I was doing, and I didn't want to risk it. I just want to get things working. So back here, you've got a Kotlin version. You've got the Android Gradle plugin, the AGP, which I needed to bring up from compatibility. Also set here. Then you've got the Kotlin Multiplatform plugin, which isn't specified in any of these files. It's just literally the one sitting in, I think settings, just go plugins. Here we go, 0.8.1. As you can see, there's actually a newer one, 8.2, but this looks like it's for the Canary version, the alpha/beta version of Android Studio Jellyfish. And I'm still running Giraffe. And if I go to do an upgrade, it's going to prompt me to try to upgrade to Hedgehog. I don't seem to need it, so I'm going to stay on Giraffe again. I don't upgrade unless I have to. This older version of Android Studio seems fine. This automatically had an update option, which I think I pressed. Obviously not updating these other things, so I'm not using them. Funny seeing Erlang Racket in here. I'm not actually using Android Studio for those things. I think I just was playing around and decided to do that. And we already decided we're not going to use SQLite, but it's still sitting in there. Anyway, this is automatically, according to this is up to the latest, either matching Giraffe or stable version. Either way, it seems to work. So you've got the plugin version, you've got the JDK version, you've got the Android Studio version, then you've got the version of Kotlin itself, then you've got the Android Gradle plugin. So how many versions is that? Let's see, Android Studio 1, JDK 2, plugin 3, Kotlin version 4, AGP version 5. So that's 5 independent aspects or tool components that have their own versions that had to be upgraded. Then we have a bunch of settings that changed that needed to be removed. Then we have the compile and target SDK. So that's 6th version. The minimum is still at 21, which is Lollipop Android 5.0. So we're still keeping the minimum, but I was getting all kinds of errors saying you need to be on 34 for these other things to be working properly. So I just went ahead and upgraded the target. I believe 34 is Android 14. I know 33 is Android 13. I don't think there was one in between there. So that's 6 independent version changes. We're not done yet. A couple other things that require new namespace option matching. There we go. The version of Compose itself. So that's 7. And then the version of the Compose compiler, that's 8. And then for Kotlin Multiplatform, if we're talking about the deployment target for iOS, I guess this is more on the iOS side, 12. So what did we say? 8, 9, potentially 9, 8, 7, 9. That's a lot of versions. And you've got to get all this stuff working properly together. You can see that stuff was changed in 2 places because I couldn't figure it out. And then it injected this. I think I pressed the migrate me through the AGP upgrade, and injected this for some reason. It seems to be benign, so I just left it in there. But did it all work? That is the question. Well, as far as I can tell, I was able to build and it worked. So at least it built the stuff on the Android side that I needed. And then I built the iOS side and it seemed to work. So I count myself very lucky. Usually when we go through these massive version upgrades, operating system, Xcode, I didn't upgrade Android Studio, but I upgraded all the versions of the things the project relies on. And it, with some code patches here or there, it worked. So that's a good day. But I want to comment one more time. Let's go back to the raising the minimum. So this is a little concerning. Our previous minimum was iOS 11, and we decided to raise 12, that we'd be okay with this. Now, according to this, we'd lose 1% of the market, but this is an overall percentage number of the market. This is kind of old. It hasn't been updated in a while. I haven't done updates since I think 16.3. As you can see, I've not gone through and done the necessary thing to update these percentages, but we actually have our own percentages based on our install base of customers. And one of the issues I had is I was thinking going forward with the new code on the iOS side, although mostly rewriting it in Kotlin Multiplatform and Kotlin, that I would start using Swift UI where necessary for custom UIs on the iOS side. Unfortunately for Swift UI, the minimum is iOS 13. It's not available on iOS 12. And the minute you go to iOS 13, you can see there used to be a difference between 98 and 96, or 99, 96, 3%. But for our numbers of our users, I actually determined that it was 5%. We would lose 5% of our existing customers would not be able to upgrade to a new version of Rehearsal Pro if I bumped the iOS minimum up to 13 in order to use Swift UI. So I decided against that. I thought that was unwise, and it wasn't important enough to alienate existing users. And as you can see, that 13 is a significant boundary here where you lose support of this iPhone 6 Plus back. Yeah, these are pretty old phones, but a lot of people use old phones. Not everybody, has the riches they can constantly upgrade. So this goes back to 2014, 10 years ago. And I didn't want to kick out 5% of our users from new releases and the new feature sets in Rehearsal Pro. So we kept it at 11. But having to move it up to 12 hopefully doesn't have that negative an impact, because as we can see, any phone that was on iOS 11, so the 5S, the 6, the 6 Plus, is upgradable to 12, not upgradable to 13, right? 12's the dead end here. So very likely, because people using phones, although I still have seen installations with reporting that the iOS installed is 11. But you know how Apple's constantly pestering us with our devices to upgrade to the latest. These customers are at least capable of upgrading to 12. So I guess it might be, for those that didn't want to upgrade, they're not necessarily blocked from it, but they would need to upgrade on their own phone to use a new release of Rehearsal, or just be happy with the older releases. So don't feel so bad about that. Not so much of a problem. We'll see what happens with the future on that. And then these are the phones, and then on the iPad side, it's kind of the same situation. We go all the way back to iPads here, and we can see that it's the same situation. I think it's because of the particular Bionic chip that these things are sitting on top of, right? These are prior to M1, so these are the Bionic A chips. I don't know, 13, 15, 14, 9. I'm not sure exactly which are which here. I don't really have it on the chart. I don't think it's that relevant. And do I have it on the chart, actually? I have a bunch of other stats on here. The prices, I've got resolutions, which pencils the pads use, P1, P2, memory, the default memory of the low-end devices, not the added memory devices and all that sort of stuff. I'm going on and on about this, but I don't know, hopefully you find this sort of thing useful. This spreadsheet has been of great help to me. Anyway, we've moved up to 12. We're happy with that. I don't actually have a latest iPhone 15. I don't really have any of these new generations. My newest iPhone, hilariously enough, is an iPhone 8. So the minute 17 came out, I couldn't even update my device. And I didn't want to have to just use the simulator for everything. Fortunately, I did buy recently, well, I guess, I don't know how long ago, maybe 9 months ago, 6 months ago. I bought the 9th gen iPad because I was debugging some issues with the pencil. And as you notice, the iPad, even the latest gen, still uses Pencil 1. All the other models of iPad are on P2, Pencil 2. Well, this is Pencil 1, which I have that pencil, and I was debugging and troubleshooting, fixing some issues we had with the pencil there. And this one goes up to 17. So I have this device on 17, and for the phone, I'm using a simulator. And then we have other folks in our group, our organization, who are testing on the actual devices. So we're pretty well covered there. The picture on Android's a little different. So downside of Apple, they control all the hardware. The upside of Apple is all of their hardware fits on this one spreadsheet. Going all the way back to 2012. Obviously, it goes older than that, but that becomes irrelevant at some point for the work that I'm doing. But Androids, there's a lot of Androids out there. Dominated by Samsung, mostly. That's why we see a lot of Samsungs here. And I haven't updated this chart to some of the newer devices. My latest Samsung is actually an S10e. It was on a Note 9, but for some reason, the cell antenna went bad on it. It's happened to me now on 2 phones. I have the iPhone 8 cell antenna's gone bad. Wi-Fi still works. The cell antenna doesn't work. And the cell antenna has gone bad on this Note 9, which is too bad. I really like this phone. It's got a pencil and stuff. But the S10 is not too bad. Anyway, helpful charts. Good to keep track of what's going on. Let's get back to the meat and the substance. Anything else about the upgrades? Nothing you need to worry about? Well, you're not worrying about anything, but nothing I need to report on, I don't think, at this point. All right. Where are we? We're actually running in the debugger right now. Here's the latest Rehearsal Pro. We are going into a script. We were looking at the line sets. We are opening up a line set. And now we've run into some new code. The issue here was we've rewritten the line set and line scenes to no longer be stored as a core data ORM type object, ORM being object relational mapper in SQLite. That's what core data does. It basically is an ORM provided by Apple. And we've talked about all this already, so I don't need to repeat myself. Just trying to level set the conversation here, or the monologue. Someday I'll do this live on YouTube and it can be a conversation, which would be kind of fun. For now, monologuing. And at this point, I went ahead and did some rewrites here. I was recording a video, but I was having problems with OBS, so that video was no good. We're now recording at 60 frames a second at this desktop resolution, which is 4K, I think. So hopefully it'll come out clearer, nicer, smoother. But I had to really mess with OBS Studio to get that working. Once I upgraded to Ventura, I slammed into some issues with the encoders and stuff, but I've worked that out. So hopefully this is all sound synced. Mouse is moving smoothly, looks nice. So what's going on here? The old code used to go to is completely synced. We rewrote that. We're now going to our internal function here. And when we go to this internal function, and what does this do? So we're clicking through this line set. We're trying to get down to the line scenes, the lines themselves in the set. And this is going to check and say, look, does our phone have the replicas from the server? Are we in sync? Or do we have to go out and get updates? So that's what the start sync line set. This is a legacy function that I have already started rewriting. So let's go to that function and see what it looks like. Okay, so it skipped over. We didn't go to that function. Let's keep going. Okay, this thing is going to get called twice. It gets called when we're looking at the top of the list. It'll also get called when we click on an individual line. So let's click on an individual line. So these are 2 calls to this function. Again, this is a legacy function that I did not change the name of, but decided to redo the logic on. And here it is. And in fact, let's put a breakpoint here so we can see what's going on. Let's close this out. I've increased, whoops, that's not what I meant to do. I meant to do that. And okay, and I've made this font a lot bigger. Hopefully it's more readable. So this would start, this start sync line set would, if it had that logic where it said, look, we're out of sync, let's call this and let's start syncing. I'm replacing this. I'm replacing all of this code with code on the Android side because that's the goal. The goal is to begin to rewrite as much of the app as possible in Kotlin that's shared between Android and iOS. And this particular task that I've been spending a long time on, that you, from all these videos, I think this is going to be the 16th video, probably the longest running task I've had on this project, because I decided to bite off a big chunk of refactoring and rewriting work as part of it. The bug here is that the line sets, part of the synchronization is causing them to get duplicated in certain scenarios. So rather than going in and just fixing the old Objective-C code and making it work better, it's the opportunity to say, let's rewrite this code, redo the synchronization so it'll be the same logic on both platforms. And part of that rewrite process will educate me on the logic that's broken. And the other videos you saw that I went through a lot of that and saw all these kind of crazy state machine flags all over the place, which is probably what's creating the problem. So by rewriting this synchronization logic, we'll fix it and we'll have rewritten it and we'll be on our way to doing things in a new way going forward. Big task, but an important task. So I started to pull these pieces apart here. And what I've gotten so far is this is going to call out to our shared Kotlin function. And in order to do that, we have to go through the shared facade because this is Objective-C. If this was Swift, we could call these functions sitting here on the Kotlin side directly, but we can't. So we have to have this facade. So we already have this facade in place. I may rename this. It's not really a facade. It's more of an adapter. Well, it is a facade because it's a collection, you know, in OO terms, and this is an object. It's a class. It's an object. So this is still OO, even though these are functions. I'm primarily rewriting things in as functional style as I can possibly do, given Swift and Kotlin. But for Objective-C, it has to have a class because that's its constraint. And this is a facade, basically one interface or one class that abstracts or gathers up or encapsulates a bunch of otherwise separate, more detailed operations in the higher level. It's not really doing that. This is more of an adapter, and probably you should call that an adapter. But here I added replicate line set. So what we're doing is we're providing the line set, and we're providing a completion to be executed at the end of synchronization if synchronization is done. So two things are going to happen here. One is, let's go back and we look at the logic. Start sync line set. Actually, let's go back to where it was called. So this is going to return a Boolean. Probably should be renamed to, did you start syncing? Are you syncing? Started, but I'm keeping the name intact for now because this will get replaced eventually. But it's basically saying start sync line set. If true, meaning you are starting to sync, I'm going to bail out of here. And that's what the original logic did. It said if we were not synced, it would actually made a call here. I've incorporated the decision to find out if as a return from this. It's not going to continue on. It's not going to allow you to play the line set because it's being synchronized. So this will return a Boolean. And the condition in which it returns a Boolean is if it attempts to synchronize, and if it needed to synchronize at all. Meaning it didn't need to sync, meaning if you got here and it was false, you were in sync, and so it continues on. And that's the case here, and it's the case where it was called in the other location as well. So back to line scene synchronizer. Whoop. Yeah, this is the stuff. This is an entire class of functions that we're now replacing. This whole thing, line scene synchronizer, is going to get replaced on that side. This is a UI class and the UI code that will call out to that. In fact, its own method. That's what it did originally. Where is it here? I've commented this out. So line scene synchronize, and I should actually put, I put quadruple comments in. Well, no, it does that to it. I don't like that. It would start up this class because everything's in a class, even though it's really just a function that doesn't really need any members. And then it would call this download. And this download is all the logic of figuring out what do I need to get, start doing the network calls and that sort of thing. And then when it was completed, that whole process was completed, it had this completion in here. But one of the things I want to do is say, well, if I don't need to synchronize, I'm just going to return false and not do any of this, right? So there is a return here. There's a Boolean return, which is, did I start or did I not start? That's why it kind of is like start sync line sets be true, starting, false, not starting. So it returns a bool. But if it starts to sync, so there are three possible answers here. One, I don't need to sync, so I return false. I do need to sync, I'm going to return true that I started. And then the sync is either going to be successful or it's not going to be successful. That success, the synchronizing success or failure, is not returned to the caller because it's asynchronous. And now here we get double use of synchronized and asynchronous. That's why I don't like calling sync, I call it replication. So we start the replication, or starting it, two possible outcomes. This replication is executing asynchronously. We've already returned to the caller here. Let's go, back to where we were. We've already returned to the caller the answer of we started the sync or we didn't start the sync. We started the replication, we didn't start the replication. If we didn't start it, we just mosey on, everything's fine. If we did start it, this logic bails out. This is the original logic in the UI class I'm keeping intact. I don't want to mess with this stuff too much, right? I don't want to pull too hard on a thread and then have, when I say thread, I mean fabric thread. Well, I'm using terminology that has been co-opted by software. Imagine a tapestry, and there are many threads in the tapestry, threads of yarn, and you pull on one and the whole tapestry unravels, and that's the last thing that I want to have happen. So, I think that's my connecting words. Back to where we were. So it immediately returns true or false. If it starts the synchronization, it's going to start that asynchronous. It's going to start the replication. It's going to do that asynchronously. And asynchronous calls in just about any approach in programming require knowing how to complete or continue on. This is continuation passing style, aka callbacks, aka, is there another word for it? I think CPS in old Lisp terminology. In the JavaScript world, you'd hear callbacks. Those can be wrapped in promises and futures and all other forms of concurrent asynchronous control. Here we're just going to call it completion. We pass in a lambda, closure lambda. Technically, it's a closure only if it needs to provide things from its environment, which it is, because these members are part of our properties / members of the class of this method that are doing the call. That's the environment of this. That makes this a closure. It has to close over its environment. When the work is done to replicate, it will pass a Boolean letting us know that it succeeded, synchronized. Let's change this to replicated. Let's try to get away from that word. Remember, we're replicating the line set. Let's say replicated. If replicated, then everything's good. We're going to reload data. Now notice that regardless of the condition, whether we replicate it or not successfully, should I say replication success? Replication succeeded? Well, replicated implies that. Even if it didn't replicate, it's still going to reload table data. This is the original code that I'm keeping intact. I'm not messing with this. But the original code also would pop up a HUD saying downloading. When the completion gets called, it would clear the HUD. And if there was an error after evaluating the replication or not and reloading the data, it would pop up an alert showing an error. I'm going to preserve that behavior, but these are generalizable, meaning making the call to this is happening within the context of this method. But as you can see, it doesn't require anything that's specific to this method of this class. This is just saying show a HUD that says downloading, say we're downloading. Once you've completed and you're calling the completion handler, clear it. And if you got an error, display the error generically. This needs to happen in the context of the actual replication, which is now being moved over to the Android side. So that's where I'm saying I need to do this, but relate this generally in the SHA, the shared side. It's going to make the call to the platform side, generalizing that. That takes care of that. Before it calls the completion, obviously the first thing it will do is it will clear it out itself. So this will happen prior to the completion call. Originally, it happened within this completion call. And then once the completion call is complete, as you can see the way it kind of brackets here, it'll call this logic, and then it will decide, I had an error, I'm going to pop up the error. So that allows us to move it over. And that's the code we're going to write right now. This function has been stubbed. Replicate line set, give me an app mutant because it's a side effectful function. Give us the line set and give us the completion you want us to call. By the way, I'm going to return a Boolean whether I even started the process, yes or no. And because of the way the app mutant works, I have to bring this back as a struct. I added this struct app mutant Boolean because I can't use pairs on Kotlin. Pairs would be nice, or some other form of tuple, but we went through that already. The Objective-C bridge messes that up for us and doesn't work well. Let me minimize this. So we have to create these kind of custom result structures where the app mutant is part of the payload, because the way the functional architecture works, anytime we're doing anything side effectful, we want to basically replace our app mutant with a new app mutant. Someday I'll explain all that. I'll make a nice video, not just raw recording here, where I walk through that. Assuming I keep that intact, it's kind of an experiment, but that's how we're doing things. So when we call the facade from the point of view of Objective-C, it's a pretty simple call, right? It just says replicate line set, here's the line set. It doesn't need to do anything other than pass the actual line set dictionary to the call. But when we look at the facade, sorry, correction. Let's go back. And a completion. So there are two arguments here. There's the line set itself and the completion that should be executed once replication completes. In the shared facade, right here it is, it's going to map to this standalone function in Swift. Now the standalone function, this is where it gets a little complicated. It's going to grab the current app mutant. Where do we have that? Yeah, global app mutant. So give me the current app mutant, make the call, replace the global app mutant at the end of the call, but then it has to return just the Boolean because the caller doesn't know anything about the app mutant, right? So it's a little bit encapsulated. Objective-C doesn't know anything about app mutant. This is delegating to these functions that say anytime we do something side effectful, we grab the current app mutant, we execute it, we pass it to the call, it makes whatever changes to the app mutant are relevant, and then we replace the global app mutant. This is the way this global mutable state is being consistently updated by any side effectful procedure. And that's what we're seeing happen here. So that's why the result has to come back in two pieces, has to give us the app mutant and the Boolean, and then only the Boolean is returned here. Be nice to figure out a way to encapsulate this a little bit cleaner. But another point I wanted to show was one snafu I ran into. So the completion handler coming from Objective-C, as you can see, here's our closure, right? So this is syntax that says I've got a closure, and this closure is a anonymous function that takes a single argument bool, meaning when it gets called, somebody will pass a bool to it. Does it return anything? No, it doesn't look like it does, because otherwise we'd see some kind of return type here. This is Objective-C syntax. In the facade, the Swift to Objective-C will translate this into, this is what the closure looks like, right? So this is a closure signature, an anonymous function that takes a single argument Boolean and returns nothing, or unit. Actually, it's funny, if you look at it on the Swift side, it's by the way, this in Lisp, Scheme and Lisp, Common Lisp would be considered an empty list. In Swift, this means unit or null, not null, unit or void. I guess the equivalent would be void. Right, and that's kind of what's implied when we look at the Objective-C, although usually you see void specified, but maybe not in this case. In Kotlin, it looks very similar. The type signature for a lambda or closure, depending how you look at it, but it says unit. So very close, using the arrow. Bool over there is Boolean over here, and unit is the return type. So we can think of this as unit in Swift. Now, Swift has this strange requirement whenever you provide closures called escaping or non-escaping closures. So if you don't provide this keyword, it treats this as non-escaping. And if I don't provide that, it's going to give me an error, which is why it was needed here. And what is an escaping closure? Well, I haven't done much research into this and why Swift uniquely needs this particular syntax, this particular specification, and other languages don't. You don't see that in Kotlin, right? So you can pass closures around and there's no notion between escaping and not escaping. Now, Kotlin sits on a memory model that is garbage collected. Maybe that's relevant because in the world of Swift, its memory model is automatic reference counting, otherwise known as ARC, just like Objective-C. So on the iOS side of the world, it's important to know the memory model is ARC. On the Android side of the world, Kotlin and Java running on the JVM is garbage collection. And if you make a closure in which you pass a lambda in which this lambda is not called, is called after this function returns, then it's considered escaping, meaning the lambda could be called at a subsequent time after this thread, this path of execution is completed, and thus it escapes. The lambda is used outside of the context of this call. So I don't know if that makes a lot of sense. So let's take this out. I'm going to take this out so we can see the error. I'm going to take it out escaping here, and this is where we're going to get an error from Swift. This is an important thing to understand. For those that don't, maybe this can be helpful. I had to learn this to get it. So it says escaping closures capture non-escaping parameter. So this completion I'm passing over to the Kotlin side. And it's going to, this is going to do some asynchronous work and return, but it's going to be hanging on to this completion, right? So it's still going to be out in memory. It's still going to have a reference to it. It's going to, on the Kotlin side, it's going to have garbage collected references to it. But on the Swift side, its reference count is not going to be 0. It's still going to be out there. It's going to be floating out there. But more importantly, it's going to be called after this return, right? If asynchronous work is done over here, and then when it completes, it calls this closure, then this closure is executing after I've returned from here. In other words, I've escaped this path of execution. That's what it means. Whereas if I simply call this completion in here, so let's say I think I can just say completion true. In other words, I use the closure being passed in as part of the scope of this particular function call or procedure call. and that I don't use it beyond that, it's not escaping, right? So I could, if I wanted to, I can show you that this will actually compile. Let's just say false. And, yeah, sorry, ndef. I'm just commenting this stuff out, basically. I'm using, I'm going to start blocking things out using the conditional compilator, and then we'll just give it a return true. Now, it'll probably complain that these other parameters aren't used. But this makes this not escaping. It's not escaping, right? A lambda is passed in. I execute the lambda within the context of this function call, and I'm out. It's not escaping. So it shouldn't complain about it needing to escape at this point. Oh, I didn't return. Let's say return false. The compiler will be okay with that. Yeah, compiler's fine. This is a non-escaping closure. Exactly my point. So hopefully that's helpful. Anyone watching this can give you a little bit of understanding how that works. But because I'm taking this closure and I'm passing it to this external asynchronous function, it has to be escapable. And I think it has something to do with arg. I'm not entirely sure. Feel free to investigate on your own. So let's just use undo, go back to where we were, escaping. Okay. But that isn't all that I wanted to show. The other thing that I wanted to show is if I try passing in this completion just as is, right? So the completion is this signature, bool to unit. And if we look on the Kotlin side, it's Boolean to unit. That seems compatible, right? And the Objective-C bridge should be fine with that. So I should be able to just pass it straight in. And as you're going to notice, I had to write other code because I couldn't pass it straight in. Why couldn't I pass it straight in? Because the compiler is going to show us this problem. Look at that. Cannot convert value of type bool to Kotlin Boolean. This is a KMP specific thing. This Boolean does not get translated to a Swift bool. It gets translated to this thing called Kotlin Boolean. And I think on previous videos we've seen this before, which is an Object-C interface that takes a bool value. We're assuming is castable to a bool value, but according to here, we can't. So how do we transform a lambda that takes a bool, returning a unit, but we pass it as a Kotlin Boolean returning a unit? Well, this is one of the nice things about functional programming is composability. I can just create another lambda, another anonymous function that I wrap around this, and I transform the argument, right? So this was saying, look, you gave me completion, which is bool to unit, but I need it to be Kotlin bool to unit. Otherwise, it's no good, because that's what it looks like to Objective-C. Is it's a Kotlin bool to unit. Actually, let's look at that replicate line set. Replicate. I always skip the first letter in case there's a capitalization. So the Swift side over there sees this Objective-C function that says, where is it? Did I miss something? Line set, completion is there. Oh, Rehearsal Boolean. This is probably a type def of Kotlin Boolean. Let's see. Rehearsal Boolean. Yep. Rehearsal. Interesting. Doesn't say Kotlin Boolean. That's weird. Completion. Well, that is weird. Anyway, it's telling us it's Kotlin Boolean. So I wrapped it in a new lambda that takes, see, succeeded, that's the argument passed in. Yeah, so this is a new lambda, which is now going to implicitly type this as a Kotlin Boolean. I don't know if I can do that. Can I do that? I don't think the closure syntax likes that. Okay, I don't know what, does it, I guess it has to do type in inference. I could look that up. There's a way to specify the types for the lambda arguments here. I'm obviously not doing it correctly. But in any regard, by wrapping this and saying, look, Kotlin Boolean comes in, then I'm going to call the actual completion, which is expecting a Boolean. I'm transforming the argument to bool using typecasting, and if that fails, I'm just giving it a false Boolean. And then whatever that result comes back, well, it's a unit, so it comes back with nothing, which is fine, it's compatible. So that's what you have to do when you need to transform lambdas from one signature to another. You just wrap it in another lambda. Just compose the function within another function that does your conversion, your transformation of types and values for you. I think this is a lot more complicated in OO because instead of having freestanding functions, you have methods sitting on objects, and so you would have to transform the object to the right type. I mean, I'm not even sure how I would do that. Anyway, there we are. So I think all that introduction is done, and we will simply start rewriting the logic for that. But how long have we been recording here? That's good. I just want to give a level set on where we are, and then on the next video, which I may do later today, we'll talk about implementing me here, the replicate line set logic. This code here is actually going to need to replace the code here in line scene synchronizer, all this logic. And this is where it dives into the line set, figures out if the replicas match. If they don't, figures out if it's line set replicas match, figure out if it's audio files replicas match. And that's where we're going to come down and find that we don't have the audio file, we need to load it. So this is what's going to get rewritten and replaced. That's a good stopping point for now. Shorter videos are probably better. I wish you the best of luck.